platform, right? But nevertheless, I think that's very important. So even if it is, kind of pushed ahead one step, it also makes a lot of sense. So in terms of the electric arc furnace, or in terms of blast furnace, when we want to start utilizing, what do you think, the steel industry should be looking for doing? What are the requirements that are there? Also, in terms of what are the kind of, arrangements that possibly they may have to do? Are there any challenges that you visualize, for the steel industry? And if you have any suggestions on overcoming them, can you throw some light on that, please?
Yeah. Hello. Yeah, thank you for last. Can you hear me? Yeah.
Yes.
So, as Mantriji has told in the beginning, that we are moving from a linear economic to a circular economy, in which the waste is not simply a waste, but it is a raw material for the next production cycle. So, coming to the steel, then I will come to the plastic. So yeah, everybody here knows that the steel industry accounts to about 7% of the greenhouse gas emission, and already most of the people are working towards the green steel. Dr. Kumar is fully aware that we are also working in the green hydrogen, green steel making, even the scrap utilization, that is also considered scrap recycling. So likewise, plastic also comes into the picture. But the plastic, all the plastic cannot be used, as rightly mentioned by Mr. Sithindu, and Manishji also here is sitting, he also understands that the most important thing is the correct management and recycling. That should be the approach. Now, as we say plastic, we generally in the steel sector, if you ask, mainly for the electric arc furnace or iron and steel industry, because we are the technology provider for the steel industry as well as in mining. So we call this material as a SRA. SRA means secondary raw material, secondary reducing agent. We never call it as a plastic or polymer, because there is a difference between a plastic and secondary reducing agent. I am taking an example of Italy, where plastic is totally banned because there is a guideline. We cannot put the plastic inside the steel making because it will involve a lot of poisonous gases. So there is a norm. So likewise, since Mantriji is also here, there should be a policy defined in India also that such type of plastic should be used for making the steel. What is SRA? Basically, SRA, 2-3 things are very important, which Mr. Shisendhu has already mentioned, that it should be considered as a reducing agent, not an energy source. That is first thing, and there should be proper way by which the plastic should be converted into SRA, that is secondary reducing agent. And definitely with the help of Mr. Manishji, those things can be, definitely it is possible. The second most important aspect that has already been touched upon is the chemical composition, that is chlorine, metal, those things has to be taken it out. Then, because if we are not doing it, those material will create poisonous gases like dioxins, and then it will create environmental hazards. Because in the steel industries, these arc furnace and those things are not designed to handle, address this dioxin, because they are having the back filter. So those things we have to take it out. So yes, it is true that we can use the plastic which are in the packing industries or food industries. There is no chlorine or any hazardous material present there. The advantage of SRA as compared to a typical carbon, it has got high calorific value. SRA is basically a processed plastic. By various process we convert into SRA. SRA is secondary reducing agent, and that should be allowed to be used in a steel sector. It has got high calorific value, low sulfur content. That is also beneficial in the case of we do the ladle refining in the secondary metallurgy. There is low carbon content. Of course, this will help for the reduction in the CO2 footprint, carbon footprint, and it has high hydrogen. Hydrogen, as I was mentioning this, hydrogen and carbon monoxide. These are the two gases which are reducing agent. Normally in blast furnace, there is carbon monoxide we use for reducing the iron oxide into iron. Likewise in DRI, natural gas based or whatever the gas is, there is a hydrogen component. Nowadays we are working on the green hydrogen, that is electrolysis from the renewable energy like wind or solar, and generating the electricity, and those electricity will go inside the water and it will create hydrogen, and then hydrogen can be utilized as a reducing agent. It is the best reducing agent, and by default in such plastic we are getting that hydrogen component. It is acting as a reducing agent that definitely helps in reducing the carbon footprint. Then, as Mr. Sindhu was also mentioning, this it is used for the slag foaminess inside the electric arc furnace, which is really beneficial for the production point of view. So we should remember that SRA is more volatile than coal. Yeah, we have to replace it, but most important thing is that we have to see that in what way we are putting the plastic. As Mantriji has told that yes, in many steel plants in India, people are trying it, but we have to also focus from the technical point of view that those plastics should not burn. It is not an incinerator. It should be to replace the carbon. So the velocity of and the momentum of that fine particle, the plastic, which is going inside, should be so fast that it should not burn. There should not be any devolatilization. It should enter inside the steel and it should replace the carbon. So that is more important. There should be proper equipment and proper design through which it can be done. And lastly, as Mantriji has also mentioned, that plastic is available everywhere, not the coal. Coal we have to source it from even the foreign countries. So there is a slogan that "Jahan na pahunche koila, wahan pahunche plastic." So that is my end comment. Thank you.
Thank you, Mr. Chaturvedi. This is something which is worth noting, that we are not putting this material to burn as a fuel, but you are actually utilizing this material as a secondary reducing agent, because you are trying to gainfully utilize the carbon and the hydrogen which is present in plastics. I mean, if you do an assessment, you will find about 75-80% will be carbon and about 10-12% of hydrogen will be there. That's a remarkable thing, and hydrogen, as you rightly say, has a huge potential in terms of building the reducing environment into the furnace, and that's where I think the efficiency of the steel making also improves, and also, as you rightly say, the slag foaming, which is another cause of concern, also gets facilitated substantially. We certainly agree with you on the equipment, because unless the equipment are proper, the benefit will not be there. So it has to be designed properly, whether it is velocities, whether it is the angle of feeding, or whether it is the size of the plastics, whatever which is required to the system, that needs to be appropriately designed and put. Then only we can get the right equipment. And lastly, you talked about emissions. So in terms, if my understanding of the system is that there's so much high temperature available up to 2000 degrees centigrade. And from my knowledge of the dioxin furan formations, absolutely at that temperature nothing can happen. However, if it is put wrongly at a wrong place where the temperatures are not adequate, then there could be a cause of concern. So therefore, from design point of view, we need to ensure that it is going at the right place, in the right manner, with the right kind of attributes, quality attributes. Then the cause of concern will be substantially less. Probably will not be there at all. There's another very important thing is that the gases which are going out, they are fully oxidized, and reducing environment for this to happen probably will be very less. The hydrogen chloride, if it is forming, and that could be the cause of concern for dioxin furan formation. The lime which is present, which is already added along with the iron, that tends to actually neutralize the acid, and therefore, so we have a lot of good environment available for utilizing the plastics in a gainful manner. Only thing is the design, I think, has to be appropriately done. One simple question to you, Mr. Chaturvedi, is do we have the knowledge base here in the country at this point in time? Atmanirbhar, we want to have that kind of a technology, capability within ASEAN. We are the second largest producer of steel. We have actually improved the efficiency of the steel production in the country. A lot of things we have done in terms of improving the technology, in terms of efficiency, etc. On this front, what is your take on that?
You are absolutely correct. We have talent, we have the vision. The only thing is that we have to fine tune, as you mentioned it, that Mr. Sindhu was mentioning that yes, there will be hydrochloric acid and it will reduce the life of the water-cooled ducts because of the corrosion. So there is a alternate method that we can also inject lime so that will neutralize because that is basic. So those things are fine tuning has to be done, because I have seen whether it in Australia, where Ms. Veena will also tell, they are putting the I have seen it, and one of the steelmaker in India, they went to Australia to see that installation. They were charging the plastic material in a pressurized manner, in a fine particle, through this slag door. But that is not an ideal way. It should be from the sidewall panel, and there should be a proper distance between the steel level as well as the point where the injection is taking place. So, and angle, as you rightly mentioned. So those equipments can definitely be done. Only fine tuning, because these are based on our experience and technology. Providers like us will definitely give a value addition to Mr. Sendhu if he allows us to do a trial in his own plant.
Sure.
With the help of Mr. Manish ji, we can produce that desired material and we can show the performance.
Perfect. That's a very positive answer, and I'm sure we can take it forward very soon. Any news about Professor Veena?